Hi, I'm Alan Wirfs-Brock. I work for Mozilla. I'm the guy that when people ask me, what do you do, I get to say, well, I write the JavaScript specification. It's actually a bit more complicated than that, but that's kind of what I'm going to talk about today is kind of the evolution of JavaScript, how it evolves, what's going on with the latest version of it, and all that sort of good stuff. So let's plunge right in. Okay, so I always like to start here by talking about, things have really changed in the last 5 or 6 years. It's pretty clear that sometime in the late 2000s, the noughts, that we made a transition from the personal computing era to something else. And I like to call this something else the ambient computing era, because it's not just about mobile, it's about computers being with us all around us, augmenting our life, and that's what the next 30 or 40 years are going to be about, I think, is the era of ambient computing. And one of the things, one of the observations I've made over my career, which, pretty much spanned the personal computing era, and actually I kind of even did some stuff back in the corporate era back there, was that for each of the computing eras we've gone through so far, there's been sort of a canonical language, the language that people think about of that stage of computing that everybody sort of knew. It wasn't the only programming language, but it was kind of characteristic of that era. Back for corporate computing was the focus. COBOL and Fortran was what it was all about. And as personal computing emerged at the same time, C and languages in the C family kind of dominated over that period. If you were doing serious personal computer programming, you probably learned C. And so the question arises, of course, as we go into this ambient computing era, what's the canonical programming language is going to be? And I think it's going to be JavaScript. JavaScript isn't the only language that's going to be out there. Clearly, there's many other languages used. But if you think about what's the one language that probably everyone is going to be expected to know, that for many people is going to be their first programming language, and is the language that you can probably always depend upon being available, it's going to be JavaScript. And so what's going on, how JavaScript evolves, the process by which it evolves, what it's turning into, is something that's going to affect all of us for a long time to come. And so that's kind of what I'm involved with. And when we talk about JavaScript, it's not just in the browser. The role of JavaScript in the browser is clearly what makes it such an important language today. But JavaScript has clearly gotten out of the browser, particularly over the last few years. It's in devices, it's on servers, it's being used to program robots. So JavaScript has now become something much more than just the scripting language of the browser. It's really a dominant programming language of this age. And so you kind of have to, ask, one of the things to ask is, well, why JavaScript? I mean, isn't JavaScript sort of a crappy language? I wasn't involved in the early ages of JavaScript. I got involved about 10 years ago. And an opportunity came up to do something involving JavaScript standards, actually. And I didn't really know anything about it at the time. And I looked at it and I said, oh my God, this thing is going to dominate the world because of the position it's in. And what could I do with my career at this point in time that would have more impact than working with the evolution of JavaScript? And so that's why I plunged in. And it's part of this, as you observe over time, it's not always the best technology that dominates. It's the technology that establishes the broad position. I kind of think of JavaScript in the age of ambient computing, kind of like the Intel x86 architecture in the PC era. Nobody thought the 8086 or the 286 was the best architecture. It was the worst. Everybody wanted to program Motorola processors or RISC processors as they emerged, and any number of companies made runs at making personal computers around those processors. But in the end, it didn't matter. The processor that was in the largest number of different computers was the one that won. And JavaScript is kind of that position because of the browser. It is the one language that is implemented in every browser platform, and the one really application platform that is available in one form or another on every platform is the browser platform. So it really just has this position of ubiquity, and it's not clear that in the short or intermediate term anything can displace it from that. So it's there. How do we make it better? How do we make it this language that is established this dominant position? How do we make it really a great programming language now for the next 30 or 40 years? So before we talk about how JavaScript evolves right now, a good place to start with is, well, how did it get started? What was the very early history? Because that actually impacts some of what is even happening today. So it all goes back to 10 days in May 1995. JavaScript, the first version of JavaScript was actually created by Brendan Eich at Netscape in 10 days of May 1995. And the fact that it was created over that short period of time impacted in many ways some of the fundamental characteristics of the language. So it was built to do basic animation, basically, within the browser to turn, to flip things on and off when you touch the button, and maybe to do some basic validation. And it was a very, very constrained environment. One of those constraints was there wasn't any error handling mechanism. There wasn't time to implement exceptions. There was no try-catch. So one of the characteristics of the language was that it was very forgiving of errors. You could, if you try to add two arbitrary values to objects, well, it had a way to do that. If you assigned to something that wasn't there, well, it created a variable, right? Because it didn't have any way to propagate errors. It just kept going forward, okay? And so many of the quirks you see in JavaScript actually trace back to some of those really early days of this very simple little language. And one of the challenges we have as language designers is how do you take and preserve that, work with that core of the language as you go forward and making it a really rich, professional quality language. So JavaScript got, since it was in the browser, in Netscape, it got, well, first of all, one question, why is it called JavaScript, right? Originally, the original code name was Mocha, and then it got the more of a marketing name LiveScript, and which kind of tells what the purpose of it was. It was a scripting language to bring some live interaction to browsers. But this is the same time, in that same year, there was this big strategic relationship developing between Netscape and Sun. And the grand scheme was that Netscape was going to adopt Java. They were going to use Java to re-implement the browser. Everything was going to be in Java. And part of all that, one of the branding things, they decided between Netscape and Sun that the scripting language would kind of look like Java, even though its original design was more inspired by Scheme. But it would they would fix the syntax so it kind of looked like Java, and they'd give it this name, JavaScript, implying that it was, just a kind of a scripting version of Java. Although it really has almost nothing to do with Java, but that's the name, was JavaScript. Okay, so Microsoft immediately cloned it and called it JScript. So they couldn't call it JavaScript because they didn't have the deal with Sun. So Microsoft immediately cloned it and put it in IE3, I think. And so you immediately have, okay, here's two different versions of this language that are almost but not quite the same. What do you do in that case? Well, you create a standard. So So a standards committee was formed under the auspices of ECMA International. ECMA used to stand for European Computer Manufacturers Association. It's one of the many venues in the world where you can get together and create standards. And in about a year and a half later, the first version of a standard for JavaScript was created. And it was called ECMAScript, and I'll explain that in just a second. But the first version of it came out in 97, and there's a couple quick iterations and where a number of significant features like exception handling was added to the language. But in 1999, the third edition of the ECMAScript standard was released, referred to generally as ECMAScript 3 or the third edition of ECMAScript. And that really defined sort of the modern baseline of Java as JavaScript. See, even I mess that up sometimes. JavaScript as it appears in browsers today. So just to be really clear about what is ECMAScript. ECMAScript is just the name of the standard for JavaScript. Some people think ECMAScript and JavaScript are two different languages. No, it's not. They're the same thing. The name ECMAScript came about because the standard process for JavaScript was going on within ECMA, specifically within TC39, Technical Committee number 39 of ECMA International. So sometimes you'll hear me or other people involved with the evolution of JavaScript talking about TC39. It's the club that gets together to decide what goes into the spec, basically. But so this process was going on originally in the first incarnation of TC39. And they wrote the first version of the spec, and they had to put a name on it. And there's these trademark issues with JavaScript, and they couldn't call it the JavaScript/JScript standard or whatever. And so somebody, I've never heard who, but somebody finally came up with what's the worst possible name we could have. Let's call it, we're here working in ECMA, let's call it ECMAScript. That name will never stick. And we'll sort this out as things go on. Well, it's never been sorted out. It's still called ECMAScript. But it's just the standard for JavaScript. Now, like I've shown the picture here on the left, I hope it's clear by now. So when you have various browsers or other JavaScript implementations, those are all just implementations of this standard. Okay, so for a while, for a number of years, people say, well, Mozilla SpiderMonkey is JavaScript, and all these other implementations are something else. And no, that's not really right. It's all the browsers implement JavaScript. They're all based upon the ECMAScript specification. One really curious thing, if you think of web standards, you probably think of the W3C. So ECMA has nothing to do with W3C. That's a completely separate organization. And TC39 that develops the ECMAScript specification has nothing to do with W3C. Other than there are some people who are on TC39 who have some W3C technical leadership roles. So there are some personal level cross-fertilization, but in terms of the kind of management responsibility, how does the web platform evolve, they're completely separate. There's no connection between the two organizations. So I was looking at this slide earlier, and I said, okay, interoperability is our highest priority, and I'll get back to that in just a second. But actually thinking about it a bit more, I think there's even a higher priority than interoperability for TC39, and it's preserving the code that exists on the web. Okay, so we're at the point now where for 20 years, there are millions of JavaScript programs that have been written and exist out there on the web. Most of them, probably almost all of them in terms of quantity, are unmaintained. There is no person who keeps them up to date. They're just sitting out there. And so, you know, our first mantra is don't break the web, right? So as we evolve the language, everything we do, we have to think about what is the impact of any change we make or any feature we add to these millions of unmaintained JavaScript programs that already exist out there. How do we evolve the language without breaking anything significant that already exists? Okay, so that's one really high priority. The other really high priority is interoperability. And by interoperability, we mean that for a given JavaScript program, if you run it on any JavaScript implementation, it'll work the same. It'll work exactly the same. And as Douglas Crockford, he kind of described it this way: with almost any other programming language or application platform, you as an application developer get to go and write your application, test it before you deploy it using the language tools and execution environment it's going to be deployed upon, and see if it works. And even if you have the same programming language, let's say you write it in C or C++, and you're very careful to write it so it runs under both on Windows and Mac OS, for example. You're still probably going to test it on both platforms. So if there are minor variations or implementation dependencies in the C compiler on those two platforms, you have an opportunity to find those and test those. With the web platform, you don't have that opportunity. As you all know who develop web apps, you just put it up there on your server, and your user is going to choose some browser to load and run this thing and expect it to work. Okay, so it's really our job. One of our jobs in TC39 is to specify the language in a way that the implementers of various browsers, of the various versions of JavaScript in various browsers, implement everything in exactly the same way. So where most programming languages, well, if you look at their specs, you'll see a lot of things that say, well, it's implementation defined exactly which exception is thrown in this case, because, or the order in which exceptions occur, or if this value overflows, then we won't predict what you get. Well, those are all the sorts of things that we want to pin down exactly and not leave it up to the implementers in various browsers to decide one way or another. Because in practice, we've discovered over the years that anything that's left that way, somebody will write some code that will depend upon the behavior in one browser, and then it will break in another browser. So because of that, we really have a very prescriptive specification where every little detail, and it's mostly specified in terms of algorithmic pseudocode. So we have just very detailed steps, and implementations are expected to produce the same result as the pseudocode would describe. They can use whatever tricks, but they have to follow that pattern. So after ECMAScript 3 in 1999 was released, then sort of the evolution of JavaScript had what I call its troubled adolescence. Right away, even before ES3 was done, work was started on something called ECMAScript 4. And the goals of people at that time, they said, oh, OK, now we got this basic scripting language. Let's try to turn it into a real programming language. And they worked on that for a couple years. And it turned out nobody was very interested in having JavaScript be a real programming language at that time. People were still trying to figure out how to do field validation and flip, pictures on and off based upon how you do a button. So that effort sort of petered out. And then for a few years, the XML guys kind of took over, and they tried to turn ECMAScript into an XML-based language and stuff. And the whole XML as the basis of the web platform movement sort of petered out. And so that really, nothing much came of that. In 2005, another effort to restart or revitalize the ES4 work started. And again, one of the problems with that work is they didn't pay all that much attention to the backwards compatibility issue. They figured, well, we could have a big mode switch, and on your web page, you'd say, I'm either running ES4 or I'm running legacy ECMAScript, and that model of web compatibility didn't, has yet to be proven practical, but because of that, they were thinking of that, they could try, and they did try some really radical changes to the language. So the language was going in a direction that was very unlike the current language. And eventually, again, it petered out. It was decided it was not going to be practical. And finally, though, in 2009, there's what we call ES5 or ECMAScript 5, which as of today is still the current standard, came out. And it was just a little cleanup over what was done in ES3. So over 10 years, there was just this, the end result was just this little cleanup. And ES5 added JSON support, object.create, what we called strict mode, which is a little bit of extra error checking you could opt into. But it didn't really give you a lot of new capabilities or new features. So, but what did happen, let me say, what did happen over that period was kind of good. Because if you guys, anyone who's been programming here in JavaScript for 10 years, remember when the biggest issue for JavaScript was performance. And if you look back here in 2008, and actually, when I was digging this up, it's actually hard to find good data from that far back about what performance is really like. But SunSpider, it was the most, and still is probably the most commonly used JavaScript benchmark. And the main thing, if you look at this picture, in 2008, on all platforms, SunSpider performance was in the 4 to 30-second range to run the SunSpider benchmark suite. Okay, and in 2013, which is the latest I actually collected data on comparable platforms, SunSpider was running in the range of 100 to 180 milliseconds. Okay, so over the course of 2008 to 2013, on all implementations, there is a major breakthrough in performance of JavaScript, over 100 times performance improvement and stuff. And if you look at this kind of timeline of evolution, you can imagine that if around 2007, 2008, this completely new design of JavaScript, ES4, had emerged, then all the implementers would have been conflicted here. Do I work on performance or do I work on the new language features? So it's probably a good thing that ES4, in fact, didn't emerge back then, because it gave time for the implementers of the language to, in fact, figure out how to make it run fast. Because the whole goal of improving the language is to make it better for running large, complex programs. Well, if it's not fast enough to run those programs, people aren't going to do that anyway. So, but what did happen, so during that period, after ES5 was done, during and after ES5, the language implementers worked on performance, and at TC39, we worked on the next version of really trying to improve the language, and we've finished it. And it's the 6th edition of ECMAScript. So you often hear it called ES6. We also call it ECMAScript 2015 for reasons I'll explain as we go on. But there is now sort of a new modernized version of JavaScript. And just a sense of the things we focused on for doing that, really the focus for ES6 was how do you build large, complex applications in JavaScript. So we focused on things like modularity, better abstraction capabilities, better expressibility and clarity in the language, and a really important thing that also emerged over this time, making it a better compilation target. Because the other thing that emerged in the browser platform is there's no way to get any other language natively built into the browser platform. So if you don't want to program in JavaScript, you have to compile to JavaScript. And so there are many languages today that simply compile to JavaScript. And so that's a use case that we try to support in this, as we evolve the language. And it's really important here, next to the bottom, that we do this all in an evolutionary manner, because we have to keep all this old, unmaintained code working. So how do we do this? So we fight about a lot of stuff, Sorts of things you can imagine is fighting about is what kind of language is this anyway? Is it a functional language? Is it an object-oriented language? If you're an object-oriented person, is it class-based? Is it prototype-based? Is it permissive? Is it secure? These are all sorts of issues we have to talk about and decide in TC39. And so how do we do this? What does TC39 look like? How does it work? People have various ideas about what a language standards group looks like and how we work. Some people think it looks like this, and it's not. It's not a big room of people where we all sit here and give speeches and vote on little issues. So it's nothing like that. Some people think it's like this. It's a smoke-filled room where guys from Google and Microsoft and Mozilla go and they trade off, It's not really like that either. It really isn't at all, even though you might want to imagine it. It's kind of more like this, actually, where it's like any sort of engineering design group you've ever been in, where people with strong opinions get there and they really scream at each other and argue for their position, and eventually you either converge upon something or you don't. But one of the important things to remember is that TC39 is actually an organization of organizations, so that we're representing companies. Each of us there is representing a company, and so you could think that we're here, arguing for the Mozilla position or arguing for the Google position or whatever. But it really isn't so much that way. I mean, we're first and foremost, everybody there is a technologist, a language designer, and we don't care who we work for. We care about doing the right thing with the language. I actually, between the time that I started working on TC39 and now, I actually switched companies once. I worked for Microsoft, and now I work for Mozilla. But, my position didn't really change. This is what a TC39 meeting actually looks like. Kind of boring. Not everybody's there. Some of them are out of frame. Brian, one of our Microsoft guys, is trying to fly. I don't know. But yeah, now this is what a TC39 meeting looks like. Now, there's a lot of stuff in ECMAScript 2015, or ES6, if you will. Just by comparison, ES5 had about 250 pages in its specification. ECMAScript 2015 has, last time I checked, which was Monday, 591. So it's really a lot of new stuff has gone into the spec. And here's just a lot of features. I'm not going to talk about all the new features in ES6. There's lots of resources out there about what's new in ES6, how to use them. There's a talk tomorrow about Tracer, which is one of the transpilers that supports ES6, and I'm sure they'll talk about some of the new features. But there's really a lot of new stuff in the language, and I encourage you to go out and just read the material that's on the web. There's a whole community, sort of onion layers, if you will, beyond the TC39 language designers who are basically self-appointed explainers of what ES6 is all about, and explaining the features and how to use them. This picture does not show up at all well here, but there's a good website that actually tracks progress of the implementation of ES6 features. So all these features are being actively worked on the browsers, and much of ES6 is available today. But you can watch that. So, okay, so I'm going to get here now into kind of some of the design process, what sorts of things we have to think about, and the sorts of problems we face in developing ES6 and stuff. First, one of the things I mentioned on the side, you said, well, JavaScript now has a class syntax and stuff. And to some people, that's a very controversial thing because they think of, well, JavaScript was the popular non-class-based object-oriented language, and that's kind of interesting. Yeah, again, this slide, the colors don't show up well. But it turns out JavaScript, from the very beginning, has had an eternal pattern for describing things that are like classes, and which are commonly used over and over again. And you can diagram it out, which is what I tried to do here, in terms of how the objects are all wired together and stuff to represent a class. So it was all there, latent in the language, and used pervasively, but there's just no way to write the syntax for it. So, for example, in ES6, so over here on the left, you have the code prior to ES6. This is sort of ES5 level code, and it sort of shows how you imperatively wire together that object structure to create the equivalent of a class. And so every time you wanted to have a class-like abstraction, you would have to either write a sequence of code like this or use a library that had abstracted it and did this for you. So over there on the right is the way you say the same thing in ECMAScript 6. There's a little declaration thing, and it creates exactly that same data structure that I showed on the previous slide, exactly the same data structure that's shown here on the left. And that's kind of an example of how we've tried to approach things in ES6, is to take what people do and then make it easier to do it and stuff. So we haven't changed anything. We haven't taken away the fundamental prototype-based nature of inheritance in JavaScript. We use it just like it's always been used, but we take what people do most commonly and made it more convenient, easier to do. And that kind of leads us, talk about kind of our dilemma as language designers is, you want to do the neat new thing. You want to be modern. You want it to be up to date and beautiful. But you're attached to this base structure that isn't, okay? And you got to be real careful because if it's really easy to have a design that kind of looks like this, is it combines the old and the modern in a way that clashes. And so we try to avoid that sort of clash. And in particular, there's all this baggage going back to the 10 days in May. And we got to work around that baggage and figure out how we live with that, how we survive with it. And so I'm going to talk about some of the specific problems we faced and kind of how we approached them and how we kind of juggled this idea of living with the baggage but yet making improvements going forward. So we're trying to fix problems that people had with JavaScript. So one of the problems that people have had for a long time, some people call it the closure and loop problem. Those of you who are JavaScript programmers probably recognize what's wrong with this. Okay, and those of you who aren't, I'll explain. So down here, basically you have a loop here, and this loop is iterating over some values, and in the loop it's computing here some local value based upon the current iteration value, and then it's going and installing in some global place a callback function, a function that's going to be called later. And the function is defined down here. And within the body of the function, it does something. It handles the callback, and it passes v and p, which are the values that were passed here. Now, what's wrong with this? Anyone want to say what's wrong with it? What's wrong with, so when you get down here and you say the object, run all your callbacks, what's going to be the value of p and v for each callback that's run? What the programmer probably thought p and v would be the value that they had for that iteration through the loop. But in fact, in JavaScript, p and v for all the callbacks are going to have the final value when the loop was exited, because the loop finishes before any of the callbacks run, and because what a variable declaration in JavaScript actually does, it gets hoisted to the top of the function, right? So this variable p and this variable v that looks like they're part of the loop are in fact global to the entire function, and they keep updating the same value, and the function closure down here is just capturing the reference to these relatively global variables, and they will have the final value they had when the loop terminated. And so all the callbacks will execute using the same value, and it's going to be buggy. And every day, thousands, if not hundreds of thousands, this error is made thousands or more times in JavaScript, okay, every day. Even expert JavaScript programmers, even people on our committee, as we sit down and write little snippets of code to explain things, you see us making this mistake because it's just too easy to make. So now you could say, well, why don't we just change the definition of var so that when you have a var here that's associated with a loop or inside a block, that it's only scoped to the block, and then you would capture the right values there, and everything would be fine. But can't do that because code exists that actually do stuff like this. Here it looks like we've declared var inside this block. If we actually change the language so var declarations were scoped to the block, then this statement down here would become illegal because var v it wouldn't be in scope. But code like this exists all over in the web, right? So we can't just make that change. Okay, so there are other issues. There's a website, I think it's called WTF JavaScript, that just captures, dozens of things like this, quirky things you could say in JavaScript. So this is just, other things in classic JavaScript, funny scoping things you can do with the variable x. Well, you can declare x as a formal parameter of a function, and also declare it as a var. Turns out it's the same binding. You could even declare it more than once as a parameter name. Does anybody know which x you get if you do that? You get the last one. You get the last one. You can have, you can declare it var here at top level of the function, and also declare var as a control variable of your for loop. It turns out it makes it the same variable. You can deep down here, you can have another var declaration. It's still the same. You can have a function down here named x2, and you might expect that you could say function x defined here, and then you do a call of x. What are you actually calling here? In most cases, it will not be this function. It actually, if you go through this loop and you take the if, you'll be trying to call 0 in many cases. So there's just all sorts of ways, literally WTFs, that you can get into with classic JavaScript variable scoping and stuff. And that's something we really wanted to fix. So how could we fix this? Well, it turns out the basic fix is pretty easy, is say, we can't change var. We can't do anything what var does because too much code depends upon it, but we can introduce a new keyword. Okay, and so in ECMAScript 2015, we now have let declarations in addition to var declarations. And a let declaration is block scoped. And a let that's in the head of a for loop is scoped to the loop and stuff. So all we need to do is introduce this new declaration, and now suddenly we've fixed the closure and loop capture problem and stuff. And so that's pretty easy. Except for it's not really all that easy because let actually is not a reserved word in JavaScript. And so we had to figure out how we could use let. There actually is one or two little quirks we had to work around to do it. I'm not going to talk more about that. But again, all we need to do is introduce a new keyword, except for we don't have any reserved keywords available to work with. So how do we get around that? So this is kind of what it feels like sometimes when you're working on this, right? Is you're here, you're up here balancing on how do I preserve backwards compatibility and add new things and make it all work and make it all better and make the world love us and so hopefully we don't fall off. So we introduced this new let keyword, okay? A new style of declaration. Well, we'd like to avoid introducing new WTFs that go with this new thing. You know, we had a bit more than 10 days to work on this. This is why it takes years and not days to evolve the language at this point in time. So you can think about all the things that now, what could go wrong with let, or how might somebody misuse a let? Like you might say, well, what if you have two let declarations, you know, in the same scope? What if you have both a let declaration and a var declaration? What does that mean, right? We still have vars. We couldn't get rid of them, so they're still around. What if you have a parameter named x and a let named x? What if you have a function named x and a let named x? You know, you go down this list of things that can have. What if down here, again, remember we still have vars, so deep down here in some block, somebody says var x. Remember, var x are hoisted to the top of the function, so what if you have a hoisted var declaration that runs into a let declaration? What do these mean? What should they do? What should happen? So we had an easy fix to this. We enumerated them all and said, those are errors. Okay, so, right? We didn't have to just define what they should do and make them work. So we could say they could be errors, okay? But it still required actually identifying all those cases, and the spec actually has to call them out and say, if you see this, this is an error, okay? The other thing we had, now that we've introduced sort of block level scoping, and we have declarations at each block contour, there's all sorts of potential WTFs you could have that relate to block level scoping. So for example, here, in an outer scope, you declare something named x, and then in an inner scope here, in an inner function, you said, you know, okay, let's print the value of x. Now, you might expect that was 1 because that was the only declaration you've seen, but right after it here we have a let declaration that says it's 2, right? And this is introducing a declaration to this block. So is this one? But we haven't initialized it yet, so maybe it's 1, or is it undefined because you're referring to the local x and it hasn't been initialized yet? Or is it an error? Should it be an error? And when you get down here past it, what's the value? Okay, so we have to think about stuff like that and come up with a rule. And the rule we came up with is with any block, with any set of curlies, basically, at a given level, a name must have only one single consistent binding. So this x here we don't want this x here and this x here to refer to completely different variables because it's within a common scope. So this guy can't be 1. And you know, maybe it could be undefined, but I'll show in a minute why undefined isn't such a good idea. But it could potentially be undefined, or it could be an error. But a similar thing you have here is, you know, since we've said this x has to be the same as that x, now we're assigning to it. So it's not a question of what its current value is, but is it OK to make this assignment when we haven't got to the declaration of x yet? And you might argue it might be or it might not be. But then you have to take into account we also have this slightly different form of x called const, which is scoped just like a let declaration. And it would clearly be wrong up here to assign to the constant x, because that would be a forward reference, and we're trying to change a constant. And we want consistency between how we handle lets and how we handle consts. And so basically, the solution was we had to say, OK, so within a block, when you have a declaration like let x or const x, before the declaration has been initialized, it's dead. If you touch it in any way, you're going to get an error. Okay? So up here, it's an error to assign to x because it's in the dead zone for x because we haven't reached its initialization point. Down here, to print x, it's an error because, again, x hasn't been initialized. So it's a dead zone. Okay? And so that's how we basically handle forward references and such. But you got to be careful because, you know, some forward references are good. Right? If you define two mutually recursive functions, you'd like to be able to forward reference to that other function. Okay? So that means that while we have dead zones, they're temporal dead zones. So they aren't based upon the actual static position in the code. They're based upon, at runtime, whether the variable has been initialized or not. And so it's called a temporal dead zone. And just, you know, in some articles about ECMAScript 6, you'll see reference to TDZs. That's what they're talking about, temporal dead zones. It's the fact that if you touch or reference a variable before it's been assigned temporally, then you'll get a runtime error. Okay. So basically, so there's a set of declaration rules here. Basically, we came up with overall to kind of summarize them. You get a single unique binding. These apply to let and const declarations. You get a single unique binding in any scope. You can still have multiple var and let declarations functions at the top level for the same name, because that's a backwards compatibility thing you have to have. Any other sort of declaration, you can't have multiple declarations. You'll get a static or compile time error if you have multiple declarations. You can't take a var and hoist it over or on top of a lexical declaration, or would be the same as saying you have both a var and let declaration for the same thing, and that's not allowed. You get a runtime error for assigning or accessing anything that hasn't been initialized. And let const class declarations are all in their dead zone until they're initialized. So just one more quick variation on this. I want to talk about, what about function declarations? What if we have here the block, it wasn't a var, but was a function declaration that looked like this, you know? And you have a function down here in the block, and then outside the block, somebody referenced it. Or what if you had here something, you know, you had, according to our basic rules, this would be an error because function should be local to this block, and G is outside it, so that should be an error. And over here, we got 2 definitions of G. That should probably be an error. Can we do this? Is this something we can add to the language here for ES6? And the first reaction is why not? Because prior versions of ECMAScript didn't allow this at all. In the standard, you cannot put a function declaration inside of curly braces, inside a block, basically. So it should be fine to do that, right? Except that real browsers let you do it. So even though the standard said you can't, browsers let you do that. And they all agree that if you say something like this, that in an if clause, you declare function G and then you call it, you're actually going to call that function G if that's all you have, which is fine. I mean, that's not inconsistent with what we would want to do in ES6. And they actually disagree on this. If you have a function G down here and you try to call it at the top of the function before you've even got down there, different browsers historically have done different things. And that's OK, too, because we would want this to be an error. This G presumably is undefined here, because we haven't we aren't in the same block as the declaration. Here's another example down here. If you get if you declare in a block G and you have an outer G, which one is this going to call? Well, browsers disagree on that. So since they disagree, every time there's disagreement among implementation, that's an opportunity for the standard to step in and say, here is what you're supposed to do. Whichever one of you is not doing that now, go fix yourself, and then you'll have interoperability. The problem, of course, is that all browsers agreed that you could do this, that inside a block, you could declare a function, and you could call it there. But then after you left the block, you could still call it. OK? All browsers allow that, which means web pages that people have created that run on all browsers, some of them do this. OK? So web interoperability, legacy basically requires that we leak out of the block scoping some function declarations. So basically, we had to come up and figure out what is actually interoperable among all browsers. What are the few things that they all do? And we came up with a hack, a specification level hack that basically says, OK, that allows this to work while still maintaining the semantics that we want to have for all the cases where people don't do this crazy stuff. And so that's a lot of what kind of developing a standard is about, is figuring out this sort of level of detail. It's not, sure, there's plenty of working on this neat new feature, adding promises or figuring out how to do class declarations. But a whole lot of it is just working down at this grungy level of figuring out how to live with what's there, how to balance up on that pull. So go back here to this picture here. We're in 2015, and you notice I'm trying to train myself to say ES 2015 instead of ES6. And the reason is because we've finished ES6, and it's being published in June. As soon as I get back home Monday, I'm sending off to ECMA the final draft to start it through the publication process. And the goal is that instead of going 10 years or 15 years between major releases and then having these big, huge, big bang releases where we more than double the size of the spec, we're going to have yearly incremental releases and kind of try to feed out features at a slower level. And so we expect that we're going to have an ES 2016 and the ES 2017 just going on at a much more sort of fixed and sustainable rate. Yeah, this is what the spec looks like. It's done. People are implementing it. Today, there are transpilers that will compile the vast majority of ES6 code so it will run in existing browsers. So you can program in ES6 today. I'll show you a list of resources in the middle, but you can track these things all down. It's being actively implemented in all the browsers. And it really is, I think it's going to be ES 2015 is like the foundation that now ECMAScript is going to build upon for the next at least 10 or 15 years or so. And so, I like to say it has legs. We've taken all this baggage we've had to deal with, and we've given it some legs, so we can go forward and into the future. There's a bunch of resources out there about ECMAScript 6 or ECMAScript 2015, and when you get the slides, you can track these down, and you won't have any trouble finding any stuff, material about them. So, time for questions. And be sure to use the mic if you have a question. No? No? Come on, yeah, over there.
So the reason you had trouble with function after you did let versus var is you didn't add a new keyword for function. Did you consider something like let function or something stupid?
We could have, but remember I mentioned there was the we don't have a big set of pre-reserved words. We had a few to work with. We could have done something maybe like let function, but we didn't think about that. We did add a new function form. It's called arrow functions, which is a very concise form of a function that doesn't use the keyword function at all. And there was some discussion of, well, let's not have lexically declared functions. Let's just use let and say, let f equals. You could actually even have a classic function expression or an arrow function and stuff. But it just didn't feel right not to support function. Plus, we had the fact that legacy browsers already allowed, most uses that the browsers had of this non-standard function feature were fine. People would declare a function inside a block and then call it inside the block as if it was block scoped. So we really wanted to explain what that meant. So yeah, back there. Oh, two of them, okay.
I was at NGConf, the Angular conference, a couple weeks back, and there was a lot of talk about the annotations they're providing for things like component and template, and that they submitted them to TC39. And I think the word is submitted, not that they've been approved, I'm guessing, but I'm not sure. Could you clarify? Because I know that the Ember team, for example, originally did a different way of doing that.
So there's a proposal. So annotations are not part of ECMAScript 2015. There's a proposal that's been submitted for annotations that we've been talking about in our meetings and stuff. And it's likely that somewhere on this train here, oops, gotta go the other way. Oh, well, whatever. Somewhere on that train, whether it's in ECMAScript 2016 or 2017, it's hard to say, and whether the proposal will change significantly is also hard to say, but that's something we're working on.
So you mentioned that your first goal is don't break the web, which is admirable. I'm glad some of my apps will keep working, despite some of the bad code that enters there over the years. But has the standards team talked about with these incremental updates going forward to eventually say, look, some of those things aren't being kept up to date. Some of those things are old. Let's break some of those things for the betterment of the language as a whole. Has that been discussed? What are the thoughts?
Oh, sure, it's been discussed and usually soundly rejected. It's okay. Who here wants to volunteer to be the first to have their code broken? So it's it is, we have made breaking changes. They tend to be things that are in really dark corners of the language that we think nobody has probably bumped into. Or if they had, it was, one crazy high school student and who knows where, pushing the limits of things. Actually, more often than not, when we do explore little breaking changes, what we find is what they break are tests that the browser implementations have and stuff to make sure they've gotten these obscurities right. But there's really no enthusiasm for really breaking anything. Now, there are some things to help things going forward. In ES5, we added strict mode. In ES6, we've added modules and classes. It turns out we've defined modules and classes so that the code inside of them is always in strict mode. So you can't, in those contexts, you do have, at least the benefit is that you're automatically in strict mode. And so there's no opt-in, opt-out. And so we do small incremental things like that. But for the most part, yeah, it's don't break the web is kind of job one.
Similar to use strict, have you guys talked about doing like use ES 2015 or use ES 2016 so you don't technically break anything? But
we've talked about that, but again, there's not a lot of enthusiasm for that. We don't think either JavaScript developers want to have lots of different opt-in modes like that they have to choose among, and not to mention potential combinations of them and stuff. And similarly, the implementers, it just complicates life for implementers to have things that sometimes work one way and sometimes work another way, which probably means more bugs and more interoperability problems and stuff. So right now, we're trying to follow a path where we don't do that. Maybe someday, we'll decide, maybe by 2025 or something, we'll decide there's so much of this old legacy stuff that absolutely nobody uses anymore. It's okay to, add in a mode, then removes it. And it could happen, but not in the short term.
An alternative to that might be to accept the fact that the transpilers now are pretty damn good, and treat JavaScript itself as what you were talking about initially, the target for the set of languages, and then have the ECMAScript be defined as a series of transpilers. So there's never any incompatibility. Yeah, that could happen. That is another path of evolution, and I think it's probably fair to say that all of us on TC39 have been surprised at the success that ES6 to current JavaScript transpilers have had in bringing ES6 features and getting them in broad use. There is still, most of the major features involve something, early on one of my slides I said, what are the things we work on? Well, one of the things we work on are things that nobody else can do. So there are some, very low-level language things that only we as the language specifiers can force the language implementers to do in their implementation, and that for a transpiler to duplicate that semantics, it has to be able to we probably have to be able to actually replicate in the transpiler a lot of what would otherwise happen at the implementation level, and it may just not be practical to do that in performant ways. But yeah, that is over the long term. We might find that there is a core JS that really becomes stable at the engine level and never changes, and everything else happens via transpilers or compilers, if you will. It's we have one up here.
Started as browser-based language.
Mm-hmm.
Now, last 6 years, it's been adopted on the server side more and more. So were there any special features that were added to the spec from the server point of view?
Well,
So a lot of work in the design of the module system, a lot of thought went into, after a certain amount of criticism, I have to say, from the external community, about making sure that it would be possible to shim it with the existing sort of style of modules that are used in Node and what have you, and how you could take existing Node modules, for example, and have a module loader that would actually take those existing things and wire them into the module system of ECMAScript 2015. Over here, I think this has been pending for a while.
So how did you solve the problem of getting let into the language when it wasn't a keyword?
Well, so it turns out, it's, you know, you don't need reserved words in all cases. If you have enough syntactic context to say, this isn't a variable reference, this isn't an expression, then you can kind of like pick any word you want. So declarations are usually of the form keywords, let, for example, followed by identifier. And there aren't any valid syntactic places, at least in the previous language, that aren't already, that weren't specified, where you could have the identifier essentially let, followed immediately with an intervening space with some other identifier. So that allows us to recognize a normal let declaration. Now, there's one complication to that, is we also have this thing in ECMAScript 2015 called destructuring, which means you can basically write a pattern, and when you assign to that pattern an object or an array, it takes it apart and assigns the properties or the elements into the pattern. And there's a form of destructuring that you can use in a declaration. So you can have an array destructuring in a declaration, which looks like let, left square bracket, some name, some identifier, right square bracket, for example, equals some expression, okay? And okay, that's a let declaration. But if you think about it, that also looks exactly like an assignment to a variable whose value is an array that you're indexing with something else. So we surveyed a bunch of code, and we basically discovered that pattern didn't actually occur enough anywhere to actually worry about. Okay, and so there's actually a special case in terms of defining a function expression. Actually, yes. So a function expression cannot start let left square bracket. Basically, if you want to assign to an array named let, to an element of array named let, you need to put parentheses around it. So far, we haven't gotten any complaints about that. But okay, so we're kind of out of time. I don't have to go anywhere, but it's.